Okay, guys, so here we're working on an application that we have. It's another form of exponential growth and decay, which we talked about last class. But specifically what it is an application that we very often actually take an entire unit to work on. It's not that I'm compressing it too much, it's just I'm hitting on the overall expectations that relate to this type of personal finance. So these are applications of exponential growth and decay, but specifically having to do with compound interest. So these would be loans, or these would be investments that had a fixed interest rate, okay? But also that, in which you didn't touch the money, okay? So the principal that you put in there was right there to begin with, and then it just kept on getting bigger and bigger and bigger, okay? Or for your loan, you don't make any payments to that loan. So let's say someone loaned you some money, and you're not making any payments to it. We are going to do something at the end of the course that has to do with making payments to sort of round out all of our learning with respect to finance and personal finance. And we won't be hitting all of the specific expectations, but we will be definitely hitting the overall expectations. So this is actually, if you look at this section, it's 8.2 and 8.3, so it's chapter 8. And it's dealing with, of course, a different unit's worth of work, okay? What we're dealing with here is what's called the future value and present value of an investment, okay? And both of them deal with compound interest. Okay, so I'm just going to read these as we're going to go along, and I'll elaborate as we go along, because this is a note that you could just read if you wanted to. One of the most important and prevalent examples of exponential growth is seen in the application of investments and loans dealing with compound interest. Compound interest takes a consistent rate of interest that is applied to a balance that is recalculated and thus compounding in value every time a percent increase is applied. In other words, if you say, I don't know, took $10,000 and put it into what's called a GIC, or a term deposit, which is basically a thing that guarantees you a specific interest rate every single month or week or day or year or half year or quarter of a year, and they calculate interest. Each time that they calculate the interest, let's say you put in $10,000 at 10%. When you put in $10,000 with a 10% interest rate that's calculated once a year, after a year goes by, you're not going to have $10,000. You're going to have $10,000 plus your interest, or a total of $11,000. $10,000 plus 10% of $10,000, which is $11,000. The next year, if this is calculated yearly, that 10% interest rate, what's going to happen is you're not going to calculate the interest on the original $10,000. You're going to calculate the interest on $11,000. So whatever you made in interest on that year gets added on to the principal amount. So then you're going to take 10% not of $10,000 and add it to your balance. You're going to take 10% of $11,000. So in this case, instead of making making $1,000 in interest, you're going to make $1,010 worth of interest. Okay? And so on and so on and so on. So what happens is that it sort of keeps building and building. It compounds and it grows exponentially, as we would expect. Okay, so that's how compound interest works. That's why it's got the name compound. It's interest that is compounded by the previous interest earnings because it's added to the total. And this is definitely an exponential relationship. Okay, if it's simple interest, which is something we're not going to cover, unfortunately, because it's an expectation that we don't have a chance to cover. But a simple interest is you would just get paid out your interest, but you would go back and calculate your interest on your original amount. Okay, so it'll be, you invest $10,000, after a year you get $1,000, and then that $1,000 is taken out, and you're still going to get interest on your $10,000 every single year, however long you have it in there. By the way, 10% interest, it does not happen. You're nowhere close to that. Okay, that's not a reality. It's just a nice round number that I can use. Okay? Now, interest is calculated on the amount of the investment at the start, called the principal value. Okay? And we use that word principal. Okay, it's actually like a definition. It's the starting amount of the investment. Okay, compounded by an interest rate that is dependent on the rate of calculation. So the interest rate that's calculated is dependent on the rate of calculation. So there's a couple of features that are involved in here. Okay? Because I could have an interest rate, and interest rates, whenever they're given by any bank or any sort of institution, they are given per unit year, always. It's called per annum. So if they said the interest rate on a car loan is, I don't know, 12%, okay? That means that even though you're going to have interest calculated probably every month or something like that, and now you're going to be making payments, so it's a little different, but the 12% is per year, okay? If your credit card rate is, let's say, 18%, that's 18% per year, but you're charged interest on your credit card balance at 1.5% because it's calculated every month. You take the 12 months and you divide it into the interest rate of 18 and you get 1.5. That's just another example. So that's the first sort of calculation and idea that we have to be concerned about. So interest is calculated or compounded, we use that phrase compounded, the same way as calculated, at various time periods. And these are the time periods that we tend to use. And this language is either Latin or something that's used specifically for the financial industries. So annually is yearly. I think most people remember that. Annually is yearly. Semi-annually is every 6 months or every half year or twice a year. Semi-annually, like a semicircle is a half of a circle. So every half year it's calculated. It can also be calculated quarterly. That means every 3 months, okay, or every quarter of a year, all right? Monthly, of course, we know what that is. That's every month, so 12 times in a year. And then weekly, every 52 days, or sorry, every 7 days or every week or 52 times a year. And there's even daily. A lot of the basic savings accounts are daily interest savings accounts where they calculate the interest that you earn in a very, very small amount. But they calculate the interest that you earn based on your bank account, your lowest value of your bank account balance that day. Okay? And they do it every single day. So it is another example of compound interest. The only problem is with your bank account balance. You tend to take money out, put money in, that sort of thing. So there's not always the same principle. So it's a bit more complicated of a calculation. We're going to deal with relatively simple calculations, relatively simple investments where we don't take money in or take money out. We don't put money in. It just stays the specific amount until the end of the investment. Okay? So the first thing we're going to look at is the future value of the investment. What that basically means is, what is it going to be worth when this investment is done? Or what am I going to owe when I actually have to finally pay back the money? Okay? So this application asks, what will be the value, so dollar value, of an investment after some time has passed? So in other words, at the end or somewhere along the whole path. And this is, of course, if you're not making any payments. You borrow some money, it sits in an account, and interest is charged. Or you take, $1,000, you deposit it into your bank account, and then you just let it sit there, and nothing happens to it except for these interest calculations. Okay, so this is just an example, and of course these are all fantastical examples. The interest rates are a bit more convenient; they're not accurate. Okay, so now here's an example. Your parents tuck away $20,000 for your education in something called a GIC, which is a guaranteed investment certificate. It's an amount where the interest rate stays the same and it's guaranteed by the bank no matter what, by law, by the Bank of Canada. Okay? When you are 4, so you're 4 years of age. Assuming that you plan to access the money when you are 17, okay, you're going to go to university after high school, okay? And most people finish high school when they're 17 years of age, all right? Maybe your birthday's early or whatever, but let's just say 17. We're not going to talk too specifically about it, okay? The formula that models this, how much will there be there in the plan at the end, okay, when you're ready for university, if you make 3%, in this case I say 3% per annum, which means per year, okay, but 3% is just going to be quoted. It's like when I do the square root sign. When I do the square root sign, it's assumed that that's a 2. When I quote an interest rate, it's assumed that that interest rate is per year. And it's compounded semi-annually. That means every 6 months or 2 times throughout the year. So the formula that models the process looks like this. Okay? You have to zoom in a bit, but that's also in your textbook, and of course it's also in your notes. A is the amount of the investment. That's the future value. That's what it's going to be after time has elapsed. P is what's called the principal investment. That's the amount of money that you put in to begin with. I is a special thing. It's an incremental interest rate. Okay? The incremental interest rate is not the interest rate. It's the yearly interest rate, in this case 3%, I'm going to turn it into a decimal. We should always turn it into a decimal. Okay? And I'm going to divide it by the number of compoundings per year. If it's compounded semi-annually, I'm going to divide it by 2. I'm going to get into this anyway, but it's good to explain it with some numbers. So my actual I is going to be equal to 0.03, my yearly interest rate, divided by, 1.5. It's going to be 1.5%. So my I is going to be 0.015 or 1.5%. Okay, because each calculation after 6 months, I haven't gone through a full year, so I'm only going to have to give part of the interest. I'm only going to have to give 1.5% of the 3% I promised per year. Okay, and the number of calculations is similarly sort of a bit more complicated, but it's fairly easy. It's a simple formula every single time. In fact, the formula that we use for this is a big I for interest rate. Okay. The actual yearly interest rate divided by something called n, the number of compoundings per year. And this is n, okay? Or sorry, I should say the number of compoundings per year. Now, for the number of calculations, I also have to know how many times it's calculated. Well, if it's calculated semi-annually for when I am 4 to 17, that's going to be a time lapse of 13 years. Semi-annual, that's twice a year. So that's what I do. I go number of years, 13, times number of compoundings per year, 2. And so it's going to be a total of 26, and that's what my n is going to be. Now, I'm going to show you in this example, okay, but it's still the same idea. And sometimes for it to be explained to you, okay, you need to kind of see it, okay? So remember this investment, $20,000 invested originally, okay, from when I'm 4 to 17, okay, so over a span of 13 years, at 3% per year, compounded semi-annually, okay? So again, I replay the problem. Your parents tuck away $20,000, okay? 3% per year, compounded semi-annually, and it's from when you're 4 to when you're 17. So my A in my formula, remember, A is equal to P times 1 plus I to the n, okay? N, all right? My A is my amount of my investment at the end, okay, or future value. Okay, I put a question mark for that. I do this kind of like a or like a grass method problem. It's great to do these like a grass method problem, just like our sequences and series unit. Okay, so you tell me who you have, you tell me who you don't have, and then you'd go from there. So I know I don't. My required is A. Okay, my given is P. Okay, remember principal is the amount you start with. So this is the amount you start with, $20,000, and then I'm gaining interest on it. I, the incremental interest rate, is I, the big I. This is the interest rate per year, the 3% written as a decimal, divided by the number of compoundings per year. Oh, darn. This should be 2. I'm going to have to correct this as we go along. I'll correct the note for you guys when I post it. Okay, but I'm going to have to correct this. But that's good. I'll show you how to do the calculation on your calculator. Okay, it's supposed to be divided by 2. That I can do in my head. 0.015. Okay? The number of compoundings per year, I'm going to have to adjust this because I'm assuming that this is monthly. That's the mistake that I've made here, Mr. Henley. Bad, Mr. Henley. Okay? So my number of compoundings per year, okay, in this case it's 2 because it's semi-annually, times my n. All right? Times my n. Okay? Which is my number of compoundings per year times my number of years. I guess you could put a y here if you wanted to for years, whatever. 17 minus 4 is going to be my 13 years times 2. So that's going to be 2 times 13. And that's going to turn into 26. Sorry about this, guys. Okay, now the only thing that's going to change is going to be this. Okay, so it's going to be 1 plus 0.015. And that's going to be raised to the 26. So this is going to turn into 20,000 times 1.015. Very easy to add this because you just put a 1 in front of the 0 point. Okay? And then you put 26 here. Now these calculations are going to be different. It's not going to be as many calculations. Okay? So I'm going to go 1.015. Okay? And I'm going to evaluate the exponent first. Remember, my bed mass is the governing feature. So I substitute into brackets, right? Put it in brackets. There it is there. Okay, I add those two together to get 1.015 1.02015, okay? And that's what I have, 1.015 to the power of 26. And then I don't want to multiply the 20,000 into here. No, I don't do the multiply before I do the exponent. I've taken care of brackets. Now I'm going to take care of exponents. Okay? So I'm going to do 1.015 to the 26. So this is 1.015. I've got a y to the x button. I'm going to do a little hat there. I'm going to go 26, and boom, it's going to be 1.472709. It's kind of similar to the other number that I had, but it's a little bit different. Now, ideally, you want to keep as many decimal places as possible because you are multiplying this by 20,000. So what's going to make sense in the dollars and cents category? Okay, so that number, whatever it is, I am going to want to multiply that by is exacting the number. So if I keep this number in my calculator, if I keep my answer, and then I multiply it by 20,000, because this last step is going to be by the m of my BEDMAS, the actual multiply step, then I'll get my final amount, okay? Which is going to be, and I'm just going to scratch this all out, it's going to be 29,454.19069 ... Okay? And those are all the decimal places that are there. Now, eventually you're going to have to round it. And this is talking about dollars and cents. So if I'm going to talk about dollars and cents, this investment would be worth 29,454 and I round to the nearest a penny. Now, the calculations are never rounded until you finally get the money out. The Bank of Canada cannot transfer you decimal values of money. It gets rounded, and that's the way that it works. Sometimes it works in the favor of the bank. Sometimes it works in the favor of you if it gets rounded up. That's the way that it goes. Okay? So now we have a problem here that we can try together. All right? Using the same technique. We've got it right in front of us here. Okay, so you max out your line of credit. Bad, not good. And ask the bank for payment forgiveness for 2 years because you can't. COVID-19 shutdowns, you don't have a job, and you're just trying to make ends meet. This is the circumstance that, unfortunately, a lot of people find themselves in. Okay? The credit line balance is $5,000. Okay? So you have $5,000. You can't make any payments, so you're going to have interest. And the bank's not going to forgive the interest, but they're going to say, hey, listen, you don't need to make any payments for a little while. Don't worry about it. Okay, so I asked for 2 years' worth of forgiveness. The interest on the loan is calculated monthly, and it's 6.8% per year. What is your balance after the 2-year period? Okay, so I want to know after the 2 years, so I don't know my amount as time has gone by. I do know what my principal is. It's my starting amount, the $5,000 that you're asking for some relief for on payments and stuff. For your incremental interest rate, what you do, again, is you take the yearly interest rate, which is 0.068, okay, and we divide it by the number of times a year. In this case, it's monthly, okay? Monthly is 12, okay? And of course, I calculate that value. I don't know if it's going to be a decimal or not. Yeah, it's a decimal. 0.056 repeating. So 0.056 repeating. Okay, and we're going to try our best to be as precise as possible when we have that interest rate in there. Okay? And then for my number of calculations, remember, it's going to be monthly, so it's going to be 12. This same number, okay, that I use here, I divide by 12 for the incremental interest rate, and then for the number of calculations, I multiply by 12 by my 2 years for my number of years that I'm asking for forgiveness on making payments on the interest or whatever else it may be. Okay? Now I have the formula I'm going to use. I'm going to write it here just because then I don't have to take up the room here. P times 1 plus I to the n. We have n, we have I, we have P. All we need to do is figure out A. Okay? So the amount of my investment, and I substitute my values in, so $5,000. I'm just going to use, it's precisely $5,000 so I can cut off decimal places, and I don't have to worry about sig figs in finance. Okay? It's going to be 1 plus my I, which is 0.05 Oh, sorry, that's 0.056. I gotta be careful with that. That would make a big difference. 0.0056. Let me just verify that. 0.068 divided by 12. I know I'm right, but either way, 0.0056 repeating. Okay, 56 repeating. And you need to keep all those decimal places, if you can, in there. And that's going to be to the power of 24. Okay? So my amount is going to be 5,000, and I leave my multiplication alone. I add that together. It's always easy to do that. A lot of people just go straight to this. Right? They just know that you take the interest rate and you just put a 1 in front because you're adding 1 to it. Okay? If you don't add the 1 to it, then it's not going to work. Okay? And it's going to get smaller. Remember, any value that's bigger than 1 is going to be growth. Okay? This is exponential growth. Okay? So any value that's bigger than 1, it's going to get bigger. Only by a little bit. It's only a little bit above 1, but still, that's an important idea. Okay? So now what I'm going to do is I've kept this number in my calculator. Okay? And I do want to do my exponent first. Remember, I'm going to do the E part of bed mass. I've simplified my bracket. I've done that simple addition. Now I'm going to do the E part of my bed mass, and I'm going to do the exponent. Okay? I've got my interest rate stuck in my calculator already. There's my interest rate. So all I have to do is go plus 1. And now I've got all those decimal places in there. Okay? And then what I'm going to go is to the power of, and I'm going to do to the power of 24. So I'm doing this 1.056, and I guess what you could do is go 1.0005 and a bunch of 6s if you put them all the way across the screen, but it's always best to be as exact as possible, especially when you're dealing with dollars and cents. And I'm going to raise it to the power of 24. Okay? So now I'm evaluating that exponent. This is the most, I don't know, stressful or difficult thing to do. So I press equals, and you're going to see that it's going to go 1.1452 ... times my 5,000. And again, if you keep this number in your calculator, if you do this interest calculation, then you add the 1 to it, okay? Then you raise it to the power of 24. You're going to get exact values all the way through. Now I multiply it by 5,000. I finally do my M part of my bed mass because that's all that's left to do, okay? And I get $5,726.21 if I round it. I guess it goes 21 ... And then your closing statement. Therefore, you will owe $5,726. Oops. Trying to go too fast here. $26.21. Okay, you will owe that amount. All right, in 2 years, if you don't pay any interest off of the principal on your line of credit. Okay. And that's the pitfall that you run into, right? In 2 years, it goes from $5,000 to $726 more. Okay, so you do have to worry about that. Okay, and you do have to make those decisions, right? If you don't have the money, you don't have the money. The last thing the bank wants you to do is to say, well, I declare bankruptcy, and you can't just declare it. It's a very complicated, long, drawn-out process. But to default on the loan, that's the last thing that they want. Okay, it's a lot more work and a lot more effort and a lot more legalese and a lot more money spent for them just to get this money back that they're owed. Okay, so they want you to be able to stay in that investment. Okay, or in this case, in that loan, and then just say, you know what, don't worry about it. You know, you're going to accrue the interest, but, you know, and go from there. All right, so that's that. All right, so that's the amount of an investment. If we have a principal amount, we know what it is, and we're going to invest it, and we want to find out what it's going to be as time goes by, or what's called the future value of an investment, or in this case, a loan. Okay? So sometimes you may have an investment goal in the future. You may be like, I need this much money in 10 years, or in 5 years, or in 2 years. Okay, like saving up for university, or saving up for a car, or saving up for anything. It could be a small amount of money. Okay? And you want to know what it is in the future. Okay, but you don't know how much I should invest now so that thing happens. So in this scenario, you're looking for what's called the present value of the investment. You're looking for your principal. And you know what the future is going to look like. You want to know what it's going to be now. Now, this is just the same formula that we used, modified. Okay, it's been basically I solved for P. That's all it is. If you take A is equal to P times 1 plus I to the N, and you divide both sides by 1 plus I to the n, assuming, of course, that that can't be 0, you're going to get P is equal to A over 1 plus I to the n, which is this. It's the same formula. It's the same thing. All it is you don't know what I'm starting with, okay? And you know what you want to have in the end, okay? So let's look at an example. But this is exactly the same. I literally cut and pasted it from the previous example. Like I didn't have to redo it. It was copy, paste. I mean, I changed this to future value of the investment, but it pretty much is the future value. Original amount's the same idea, present value, okay? And PV stands for present value or P, principal. I don't care what you use because it's potato, potato, it's the same thing. So in this example, 2 young parents-to-be, the baby's due in a week, very exciting, think their young baby will need about $150,000 for their 4-year university education, and they want to know how much money they will need to invest now so that they can reach their goal. Their best guess at a return on investment lies at 8%. Usually the investments that you do, they fluctuate with the stock market. These are mutual funds and different types of investments that sometimes can have good years and sometimes can have bad years. So what they have to do is they got to sort of play around with it and say, we expect 8% per year on average. So this is not an exact calculation, but it's at least letting them know, hey, how much roughly are we going to have to put away if this is what we assume is going to happen? So we might as well treat it like 8% is fixed. That's exactly what it's going to be. And it's going to be compounded semi-annually. Compounded semi-annually. Okay, that's twice a year. They figure that their newborn will go to university at the age of 17. I mean, that could change. Maybe it goes to 18. Maybe it goes back down to 16. Maybe they take a victory lap. I don't know. But the point is they figure 17. Again, this is looking in the future. Who knows what life is going to be like? Okay? But they do know what they need in 17 years. They need $150,000. So the amount of the investment is $150,000. Okay? The present value is, that's what they need to know. How much do I got to put into the bank? And do I even have that money? I is what's called your incremental interest rate. So what do? I take my interest rate of 8%, I turn it into a decimal, 0.08, and I divide by how often it happens per year. In this case, I actually did this one correctly. It's divided by 2. Okay, 2 because it's semi-annually. 0.08 divided by 2 is 0.04. Okay, so that's my I. For my number of for my n, my number of compoundings in total, I take my number of compoundings per year, which is 2, twice a year, and I take my number of years, 17. Well, 17 minus 0, which is 17. And I get 34. They're going to have 34 times to gain interest on whatever amount of money they put into the bank. Okay? And this is actually can be quite impressive when you look over a 17-year span. So I've got all the players. I know I need P. I've got A, I, and N. And so I plug it in. And when I plug it in, I put my A, 150,000 in here. Okay, I put my interest rate in here. Now, I did do that skip a step. I did. I said to myself, you know what? I think most of us can just go 1 plus 0.04. Okay, they can take this 1 plus I and 1 plus 0.04 and get 1.04. I think most of us are okay with that. And most people, once they start doing these problems, they just do it. They don't even think about it. Okay, so it's really 1.04 if you want to plug it in quickly, and then to the power of 34. Okay, so I put that in there. Remember, I got to do BEDMAS first. Before I divide, I have to do my exponents. So again, I go 1.04 to the power of, and in this case, 34. And I get this 3.7943, blah, 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 blah. So that's what I write down, 3.7943, da, 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 da. Okay? And then I go ahead and I say, okay, I got to calculate that. Now, if you're really clever, what you'll do, okay, is you'll use this button. It's called 1 over x. I don't know where it is in this calculator. 1 over x, 1 over x to the minus 1. Where is it? Oh, there it is. This is in a second function for me, x to the minus 1. And what this does is it flips the fraction. So it takes 3.7943 over 1, and it flips it. So I'm going to flip it. C to the minus 1, the exponent minus 1, right? It's not the inverse, okay? Although that is the same thing in this scenario. And anyway, so it ends up being 0.26355 blah, 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 blah. So if I was to include this step, I will go 150,000. Okay. Times, and most people don't do it, 2, 6, 3, 5, 5, dot, dot, dot. Okay? What I do is I keep that number in my calculator to be exact, and then I multiply it by 150. And if you guys aren't exact when you do this stuff, okay, it's not that big of a deal. And this is the number that I get. And I think what I actually did is I rounded it, to be honest, because I got $39,542, which is a little bit different than the $538. But this is how much money they need to invest. So they need about $40,000 roughly, a little bit shy of $40,000 if they get this 8% return so that they can make $150,000 for their child. Now that's pretty impressive. Okay, but that's the power of interest. Right. Now most parents don't have $40,000 lying around. Okay, so especially when they're young and just starting out their families. So we do have plans where you make payments, but the ones where you make payments we're not going to do until a little bit later on. Okay, but we'll do those ones too, so we have a more realistic look at things. Okay, now let's try one ourselves. You want to buy a car. When you get your full G license, let's say when you turn 18 to be conservative, depending on when you decide to get your license, right? You got this a 1-year waiting period. Maybe you don't get your license right away when you're 16 and all that sort of stuff. And you're now 14. So you're 14, you want to get that money and buy that car when you're 18. You are lucky enough to inherit some money from your GG, that's great-grandmother, and you want to know how much of that you want to save. You figure that you'll need about $12,000 for your car in the future. You're not going to get a brand new one. You're going to get, like most people, just a used car. But you don't want to get a piece of junk for like $1,000. You want to spend $12,000 and get something that's at least a little bit reasonable, right? And you can get a 4-year GIC paying 2.6% per annum, compounded weekly. That's a pretty good. They don't happen, but I just made this up. So we could do something weekly. Okay? So now let's figure it all out. Remember, the formula that we're looking for, okay, is P, how much do I want now or do I need now to get an amount, 1 plus I to the n. Okay? That's what we're looking for. So the first question is, what is P? In this case, I don't know it. That's why I'm using the formula in that form, right? My amount that I figure I need $12,000. The incremental interest rate is my interest rate as a decimal, 0.026, divided by however often I'm doing it. And it's weekly, so that's 52 times in a year. And I get 0.0005. Okay, but of course you're dividing it by a really big number, so it's going to seem really small. Okay? And your n, okay, is your number of calculations is, you're going to take 52, the same number, and you're going to multiply it by however many years. You're 14 to 18, it's going to be 4 years. Okay, we don't necessarily have to go 18 minus 14. I think most of us can figure out that's going to be 4 years, which is going to be 52 times 4, 208. Okay? So there we are. Now we're ready to go. We're ready to plug it in. So I'll go ahead and plug it in here. Okay, I got my $12,000 that I'm hoping for my car. Okay? I've got my interest rate. I'm just going to go 1 plus this 0.005, which is 1.005, and most people do jump this step. And then I put a 208, a lot of calculations. But of course, it's a very, very small interest rate, so we don't quite know how that's going to work out. So we go 1.0005 to the power of 208. And we get 1.10957. I'm going to keep that number in my calculator, so it's going to be 12,000 divided by 1.10957. And the more decimal places you keep, the better. If you're going to round it, go ahead and do it. Okay, but I'm not going to. I'm going to keep those in the calculator. If you do, make sure you use an approximately equal to sign, so you put a little dot over there. I'm not going to because I'm not doing that. I'm going to use my fancy 1 over x function. Okay, so it becomes 0.9. Okay, and then I'm going to multiply that by my $12,000. And obviously the amount that I'm going to need is going to be less. Rounded, it's going to be $10,814.98. In which case, you're going to make the extra about $1,100, $1,120, or $1,180. You're going to make in interest, which is good. You know, it's useful. Okay, that's $1,100 that you're not going to have to pay out of your own pocket, that you could use that money for something else now if you want to. So therefore, you will need approx $10,814.98 for your $12,000 car in 4 years. Okay? And so there's your homework. Now I've narrowed down the homework as much as I can. It's about the same as one homework assignment, but they're in 2 different sections of the textbook. As I said, this is 8.2. Sorry. This is, am I out of lead here? There we go. This is 8.2. Okay, maybe I am. There we go. This is 8.2 and this is 8.3. Okay? Not too crazy of an idea. I will go and correct the notes. Okay? You guys, unfortunately, on the video have on the Friday. So this is my period 2A'ers, my cohort A. You're going to have sort of the rough copy, but I'm going to go back and I'm going to fix this calculation, this ugliness that I've done here, so it looks nice and pretty in your notes, and you can follow along in your notes and do some doodles and stuff like that. Okay, so have fun with that. I'll talk to you later.